The topic for Chapter 6 is going to be probabilities and inductive logic. To get things started, let's look at an inductive argument that doesn't have a probability in it. Okay, so here we've got most cards in a standard deck are non-heart cards as our first premise. And this first premise is going to be true. In a standard deck, you've got 4 suits: hearts, diamonds, spades, and clubs. And only one of those suits is hearts. All the rest are non-hearts, so yeah, you're going to probably get a non-heart if you pull a card. So C is a card drawn blind from a standard deck. So you take one card from the standard deck filled with mostly non-hearts. It's the card C. You pull it out. C is a non-heart card. This is probably going to be true because most of the cards are non-heart cards. But let's say, for example, you and a friend are interested in putting a little money on the card drawing exchange that's about to happen, but you want it to be a fair bet. The information that we've got in this argument here isn't sufficient for you to do a fair bet. To do that, we're going to need to do something more specific, something like this. Premise 1. 3/4 of the cards in a standard deck are non-heart cards. Premise 2. C is a card drawn blind from the standard deck. So our second premise is the same. All we've done for the first premise is make it more specific. And then conclusion, the probability that C is a non-heart card is 3/4. We determine that 3/4 of the cards in the standard deck are non-heart cards by taking the total number of cards in the deck, 52, and seeing how many are something other than hearts, 39. That gives us 39 over 52, which reduces to 3/4. So here we've got an inductive argument. We've got a true premise up here in the first premise, then an extra piece of information about this card we're about to draw blind, and then from this we conclude a probability. The probability that C is a non-heart card is 3/4. If we're interested in placing a fair bet, like I said we were in this situation, one in which the odds reflect the probability that a certain outcome will occur, we prefer to assign a numerical probability like 3/4 of the cards are non-heart cards, as opposed to the less precise most cards in a standard deck are non-heart cards. The probability of 3/4 or 0.75 is what determines proper betting odds. The amount of money you put up at risk on a bet is called the stake. So if I bet you $1 that the fair coin I'm about to flip will land on heads and you accept, your dollar is the stake in the bet. In an even money bet, the amount won or lost is equal to the stake. So the case of a single fair coin toss bet would be an even money bet because you would win or lose $1, the amount equal to the stake, depending on whether the coin landed on heads or tails. In an even money bet, like the coin toss case, where either option is equally probable, the odds are 1 to 1. When the probabilities of various outcomes are not equal, the betting odds can be altered in an appropriate way to ensure fairness. For example, betting odds of 3 to 1, in which the return for a winning bet is 3 times the stake, are fair for an outcome with 1/4, or 0.25. In such a case, there are 3 times as many ways of losing as there are of winning. So if you've got 4 outcomes possible, only one of those outcomes is going to be one where you win when the probability is a 4th or an 8th. And that's why you set the odds of 3 to 1. 3 for the amount of ways you could lose, 3 for the amount of ways you could win, and 1 for the amount of ways you could lose. Or, if there's 8 options and 6 of the ways results in you winning and 2 of the ways result you in losing, that still reduces to 1/4, and then the odds are still going to be 3 to 1. Odds are the difference in favor of one side and against the others. For an outcome with a probability of 1/4, such as blindly drawing a heart from a standard deck, the odds are 3 to 1 against winning. A payoff of 3 to 1 balances this disadvantage and makes the bet fair. For an outcome with a probability of 3/4, like drawing a non-heart card from a fair deck, the odds against winning are only 1 to 3, because the odds are a lot better that you're going to in fact pull a non-heart card. So an accordingly smaller payoff balances the advantages. So changing topics for just a second, your book identifies 3 different types of probability, by which we mean 3 different kinds of things that we can be talking about when we're talking about probabilities. One is the ratio of favorable to possible outcomes, another's the observed relative frequency, and a third one's the degree to which it is rational to believe certain statements. So this is talking about the nature of probability in terms of what is it that we're dealing with when we're dealing with probabilities. For right now, we're not going to go into the details of any of this. If this is something that interests you, read through that section. Feel free to ask questions via email if you're interested in more resources on types of things we could mean by probability. There's also a philosophy class that deals with philosophy of probability, Philosophy 350. Dr. Paul Draper usually teaches that. So if that's something you're really into, something you might want to look into, but for now, we're not going to do anything else with types of probability. And starting in the next video, we're going to start looking at the rules of the probability calculus, which is, we'll talk about that in the next video.